Question 42 combines the use of an annuities in advance, someone building up amount of money to a future fund, checking it via the graphics calculator finance solver, and then seeing, using the annuities in arrears variation, how much money is left after a certain amount of time. Now, I've got to be honest, I really think that it's better using the finance formulae and the TVM solver. But an advantage of using the sequence and series generator or the recurrence relationship is it does give you a tabulated data set. So we've got to work it out to begin with. So 6 divided by 12 divided by 100. And the difference is 60. So our equation becomes 1.005 times t to the n plus 60, starting off with 0. Now, if we generate that on our calculator, you've got to make sure that when you do this, that you've actually got enough readings to record it. So 16 years is going to be just under 200, so I've had to change that. So I've got to scroll all the way down to 192 payments. This is a big disadvantage with this generator. It's easy to overshoot. So after 192 payments, she'll have $19,361.81. Now, you're asked to confirm this using a suitable finance formula. Now, I'll use the annuities in advance, but I'll generate it on the calculator. So I want 192. I'm going to have 6%, present value 0, payment of $60, PY and CY is 12, and set this at the begin. So when you set this up, the standard finance format that if you haven't met it, you'll meet it and you'll probably get used to it in the finance unit. So setting this up, make that 0, 12, and 12. Interest is paid from the beginning, and you can see that the present value, wrong one, future value under that build up is very, very close. We get 19361.81. It's exactly the same. So just record that information as you go. Now in part D, they stopped paying into the fund and she's paid an allowance from the fund. So this is a bank paying out an annuity. So our initial figure is 19,361.81. We're now dealing with an annuities in arrears case. We've got to make the assumption that's still 6%. But it becomes an annuities in arrears. Now, after 4 years, we want, in this instance, to the n plus 1. If we start with the 0, we want 48. So we'll just find out what that figure is using the calculator. So I go back to the sequences and series. What is different, though, is that we're using a repayment. So times it by AN minus 250, and the initial term is 19,361.81, and I generate it, and you can see the tabulated data appearing. So I'm going to run down to 48, and we'll see what we end up with. So after that time period, we've got 11,074.51 remains. Now, if you want to confirm that using the financial formula, we go to the TVM solver or the financial solver. I'll just pause the tape. So we're now looking at what happens after 48 months, 6%. We have 19,361.81. Payment is going to be -250. So it's the bank paying her, if you like. Future value, I don't know. And we change it to end. And you'll see the future value at that time is equal to the 11,074.51. So just showing you how they both work. They're different functionalities. The sequence has the advantage of giving you a payment schedule, which is quite neat. The TVM solver is a lot more versatile though. Now we want to see how long that will last. So I'll scroll back down. We're back in the negatives by the time we're into the negatives, by the time we get to 100. So we can see it should last about 98 months, plus a part payment. There'll be a very small payment left between the 98th and the 99th term.